Okay, we are on 10.6 polygons. There are a lot of notes on this, so I had to make it pretty small. So if you see me going off the page, try and fit everything onto your page, because I don't know how small I'll be able to write with the pen. Alright, polygons. Couple things we're going to do with this. One, we are going to be able to name polygons. So down here, these polygons, you are going to be responsible for knowing. Triangle, any three-sided shape. You won't have to be very specific right now on these, just that a three-sided shape is a triangle no matter what kind it is. Quadrilateral, you will have to be more specific on quadrilaterals because we did do that in this chapter. So you have your whole page full of quadrilaterals, your squares, rectangles, kites, parallelograms, trapezoids, all those. Pentagon would be a five-sided shape. Hexagon, 6 sides. Heptagon, 7. Octagon, 8. Nonagon, 9. And decagon, 10. So find ways to try and remember those. Deca is like a decade. That's how I remember 10. I remember nonagon because it starts with N, like 9. Octagon, like an octopus that has 8 legs. So basically these two are probably the trickiest one. 6 has an X in it, so that's how I kind of remember that hexagon has 6 and heptagon has 7. Pentagon, you can think about the pentagon building with the 5 sides. Alright, so going up to polygon. Polygon is just a simple closed figure and I am not going to be able to fit it all, so you fit it in your box and I'll keep writing. Formed by 3 or more line segments. Okay, so that could be as simple as a triangle, or you could have some goofy shape like this, and as long as it's all line segments, straight lines connected, and it's closed, it is a polygon. Alright, diagonals. A diagonal is a line segment in a polygon that joins two non-consecutive vertices. So it is a line segment try and get smaller. In a polygon, that joins two non-consecutive vertices. Alright, so if I have a square, non-consecutive means I can't go from this corner to this corner because that's already a side of the square, so that can't be a diagonal. So the diagonal has to go from non-consecutive, from one to an opposite, so I can't go from here to here either. So I can only make one diagonal in this square. Let's make a pentagon with 5 sides. And to connect the diagonals, you always start at one point. You can't start at another and crisscross. So this is the only one you have to start at one point. It doesn't matter which point, but you have to start at one point to make your diagonals. Can't connect to this vertice because it's right next to it, or consecutive or in a row. But I can connect to that one and that one, not this one. Okay. Let's make a hexagon with 6 sides. Hard to draw straight lines with this. I'm going to start in this corner. I can't connect to this vertice, but I can connect from here to here, from here to here, and from here to here. Okay? Imagine those are supposed to be straight lines. Those are all diagonals, and we're going to come back to those diagonals and the triangles inside of them. Alright, interior angles are angles inside the polygon. Okay, so here's my triangle. Interior angles would be these angles inside. Okay? A regular polygon is a polygon that is equilateral. Polygon that is is equilateral, which means equal sides. Alright, so that would be your squares, your equilateral triangles, and then any other shape that has markings, the little hash marks all the way around to show that they are equal. Okay, a regular polygon, equilateral and equiangular, which means equal angles. Okay, lateral means side, angular means angles. All right. Okay, so I want you to look at the triangles in the polygon and the number of sides versus the number of triangles that are in there. See if you can figure out a pattern there. I've got 4 sides and 2 triangles, 5 sides and 3 triangles, 6 sides and 4 triangles. The number of triangles inside each polygon is 2 less than the number of sides, and we're going to use that to help us figure out the sum of the angles in a polygon. So we're going to complete this concept map to find how the sum of the measures of the interior angles of a regular polygon, those are all its sides and angles are congruent, and how to find the measure of one interior angle. Alright, so first we have to count the sides or vertices. So here we have 6, right? 6 sides or vertices. We're going to subtract 2 from this number because there's always going to be 2 less triangles. And we are going to multiply by how many degrees in a triangle? 180. Okay, so we have to figure out how many triangles there are inside each shape. Just like on a polygon there were 2, so right, we did 360 for what it equaled. Now we just have to subtract 2 from the number of sides, times that by 180, and that gives us the total number of degrees in that polygon. To find the sum of the measures of the interior angles, so that's all the angles. Okay, that's all of them. So this one here at step 2 gives me the sum of the angles. Okay. Here, if I want to get one angle only in a regular polygon, and this only works for regular polygons because all the angles would be equal, you could, for one angle, divide this sum by the number of sides. To find the measure of one, this is one interior angle. Okay, so this is for one angle, let's add on there, of regular polygons. That's important. You can't do this with any other polygons. They have to be all equal angular so that you can divide by the number of angles that it has. Alright, so down here, let's make like a formula out of this. If I want to find the sum of interior, oops, sorry, I'm supposed to say interior angles, n equals number of sides. We take the number of sides and take away 2. I'm putting parentheses around here because you want to subtract that first before you times by the 180. And if you type it all into the calculator, it will times before it subtracts. So make sure you subtract it in your head and then times that by 180. Alright, but when you have to write it out for homework, you'll have to show me that formula and plug the numbers in. If you then want to do, so this is for sum, this is if you want one angle of a regular polygon. You do the exact same thing, right? I got to find the total degrees first, and then I take all of that and divide by the number of sides, and that will give me one angle of a regular polygon. All right? Show more of that. Okay, now we're going to classify. So we classify, and it wants to know whether it's regular or not regular. First of all, it does not appear to be regular. All right, the angles are not the same. I can see right here that the angles aren't the same. Then I count 1, 2, 3, 4, 5, 6, 7. 7 is a heptagon. Okay. Looking at this one again, nothing looks equal, so it is not regular. Regular means that they would all be equal angles and equal sides. 1, 2, 3, 4, 5, 6, 7, 8. There are 8, so it is a octagon or an octagon. This one here appears to be regular, right? It's a quadrilateral, but more specifically when we're naming shapes with the quadrilaterals, it is a square. All right, we're going to find the sum of the measures of the unitary angles of each polygon. So we are not finding just one, we are finding the sum. So when we find the sum, a quadrilateral has 4 sides. Take away 2 times 180, and you get 360. Even though we already knew that, we're practicing these. I'm going to bring these down here. You write them on your paper. A nonagon has 9 sides, so when I give you the names, you have to know how many sides they have to do these as well. Times 180. So you do 7 times 180 on your calculator, and you get 1260. Just put the degrees in here. A heptagon has 7 sides. So 7 minus 2 is 5 times, so there's 5 triangles in there, times 180, and I get 900 degrees. A 12gon. Now, beyond 10, you're going to see this. Instead of coming up with any other names, even if some of them do have names, they're just going to take the number of sides dash gon. So that makes it really easy. This has 12 sides. Take away 2, that's 10, times 180 is 1800. That's supposed to be 1800. Okay? All right, so let's write that. Can we squeeze that in here? Greater than 10 sides is number of sides dash gon. Just put that on your paper somewhere. So if it had 14, it'd be 14 gon. If it was a 20, it would be 20 gon, and you would still do this the exact same way. And then remember, on your homework, there's going to be somewhere you have to do, you are going to show work, so you're going to show it just like this. There's going to be ones where you have to do them like this, where it says the sum. And then as soon as it says the measure of an interior angle, let's say that you would, if you wanted to find one angle of a regular octagon, you would do 8 minus 2 times 180, and you would have to divide by 8. Okay, so you would do this, multiply out times 180, and you would have, 1080. And then you would have to divide that by 8. And that means each angle, if it's a regular octagon, each angle in that octagon would be 135 degrees. Okay? All right. Make sure you show your work on your homework. 1 through 14, the practice page for 10-6 is the ones like this where you have to show work. And then it's just some identifying, and 15 and 16 on the homework when you do the identifying. I don't need anything very specific. If you think you see one hexagon, you only write it once. If you see a square, you only write it once. If you want to say quadrilateral for every 4-sided shape, that's fine. So you're not writing tons and tons of shapes.